So let's start chapter 20 practice problems. Let's do number 1. I already started it here. We have a 24 ohm resistor down here that is connected to a 12 volt battery. Now when it gives you the voltage of the battery, that's the EMF of the battery. That's this part right here. But it could be that the battery has some internal resistance. That's what I drew right here. It's a little r. It doesn't tell us anything about it. The reason that you know that this one probably has some internal resistance is because it specifically asks for the power output delivered by the EMF. Whenever it mentions EMF, then you're talking about the more realistic battery where the terminals of the battery are here from A to B, and you get a certain voltage from the actual battery, but there is this internal resistance R here. So it's just asking us about how much power is produced here by the EMF. So what I'm going to do is I'm going to use the equation P equals IV or IE. Because it says that we're going to have this current flowing. When it's all connected, we have that current flowing through the whole circuit. When I plug in 0.482 times 12, I will get 5.78. Now the trick about this one is that you may have wanted to use P equals I squared R, for example. But if you did that, then you would have gotten 5.57. And that's because when you're using these values, you're finding the power dissipated through this resistor. But that's not the total power provided by the EMF source because we have some power dissipated through the internal resistor here. So the 5.57 is not the complete answer. It's only part of the power delivered by the EMF. Some of the power was also delivered to this internal resistance. And I actually did the problem both ways, and I saw that I got different answers. And that's how I figured that there was some internal resistance. Number 2. We have 3 resistors connected in series. What's the overall resistance? So that means they're connected in series. That means like this. And when they're in series, you just add them. So the R equivalent would be R1 plus R2 plus R3. So you just add the 3 numbers to get 14. Now over here, we have 3 resistors connected in parallel. So that means they're connected like this. It's 1, 2, and 3. So you would just use this equation. 1 over R is 1 over R1, and this is R equivalent here, plus 1 over R2, plus 1 over R3. All the R's, these are the 3 R's here, they're all 4 ohms. So you're getting 1 over 4 plus 1 over 4 plus 1 over 4 means you're getting 3 over 4. Don't forget to flip it. That's 1 over R equals 3 over 4. So that means that R equals 4 over 3. And that's the equivalent resistance. Alright, so that means we can simplify this circuit to a circuit like this, where this is R equivalent here. And now this is connected to 12 volts. And now we want to figure out what's going to be the current. Well, we can use Ohm's law. Ohm's law tells us that I equals delta V over R. So the current in this circuit right here is going to be 12 divided by 4/3, which is equal to 12 times 3/4, which is equal to 9. That's not the final answer. So this current here, 9 amps, we simplified this circuit to one equivalent resistor, and then we found the current in this equivalent circuit. But now it says, well, what's the current in any one of the resistors? Well, if we have 9 amps going out from the battery here, and each of these resistors must get the same current because they're the same resistors, and they all have the same voltage across them because they're all in parallel, they all have the 12 volts, then they must all get 3 amps. That 9 amps here is going to split up to get 3 amps to each resistor. So that was the answer. Now, looking back at it, just thinking about it right now, it turns out that we didn't even have to find the equivalent resistance like I did if we realized from the beginning that because they're in parallel, they're all getting that same voltage. So if you know that this right here is getting 12 volts, you know that from just looking at your picture, and you know that this resistance is 4 ohms, then you could just use Ohm's law right here and say I is equal to 12 over 4 to get your 3. So that would actually be a lot faster. So the point is that sometimes you do get kind of stuck in a rut of just simplifying everything and then working backwards, but sometimes you can just stop and look at the problem and see what you know, and you saw that that was actually the fastest way to do that problem.